Physicists say that the universe had its origin in an event known as the Big Bang, around 13.7 billion years ago. However, the question that arises is, what caused that explosion, and why did it occur? Over time, as we've investigated and learned about the history and science of our universe, the Big Bang has been the predominant explanation for everything we have observed. There has been a lot of research, and thousands of scientists have worked on it. The data collected has consistently supported the Big Bang theory as the main explanation for how the universe was created. In accordance with this theory, dark energy is a form of energy even more abundant than galactic energy and is considered the antigravitational force responsible for the continued expansion since the universe began with the Big Bang. Today's science is very different from what it was in the past. With technological advances, new theories emerge. Many times, we discover that things we believe to be absolutely true are far from being so. Mishoku has raised the official debunking of the Big Bang. This is because the James Webb Telescope has discovered 750 brand new galaxies, nothing like what was expected. This raises a new perspective and leads us to learn more about how the James Webb works. The telescope is altering our comprehension of the entire universe. Join us on this amazing journey to the far reaches of the observable universe to discover more details about the immense number of new galaxies that have been found. If you are interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video, share it to reach more people, and turn on the notification bell. The images of new galaxies captured by the James Webb Telescope are absolutely stunning. We are able to see hundreds of galaxies in a single image, as well as their beauty and power. These photos are truly stunning, something that cannot be overlooked. However, what appears to astonish the typical person is the exact opposite for researchers. These pictures are incredible to them, but they do not correspond to what scientists anticipated based on their theories. In fact, there are many more galaxies visible than expected, and these galaxies are different from the rest. They are smaller than imagined and have a truly remarkable age. These surprises are causing some anxiety among scientists. There is even an article that begins with the word panic in its title, which shows the seriousness of the situation. These galaxies are nothing like what was expected of them, based on existing theories. For a long time, scientists have proposed the Big Bang theory as the main explanation for the vast universe's beginnings. This theory predicts that approximately 13.7 billion years ago, the universe started as a result of some kind of mysterious cosmic event. However, these new images challenge the definitive tale of the universe's beginnings as previously understood. These striking images captured by the James Webb Telescope have challenged our understanding of the origins of the universe. Specifically, these images directly contradict the Big Bang hypothesis, which has long been considered an unquestioned truth by most theorists of cosmology. The galaxies depicted in these photographs appear to be too small, smooth, aged, and numerous compared to the Big Bang's predictions. In fact, the observed galaxies are 2 to 3 times smaller than those imaged by the entire Hubble Space Telescope, which defies the expected behavior in an expanding universe. According to the hypothesis, as the universe expands, objects should appear larger as distance increases. However, these James Webb galaxies defy that expectation. In addition, the smoothness of these galaxies is totally unexpected. According to the Big Bang theory, galaxies should show irregularities and changes in their structures as a result of their formation dynamics and evolution. But the pictures show unusually smooth galaxies, without the level of roughness and complexity that one would normally expect in galaxies of their age. This defies the expected timeline for the formation and evolution of galaxies within the Big Bang theory's framework. At the beginning of all matter in the universe, energy and the building blocks of the cosmos were compressed into an extremely dense singularity, a concentrated point. At this point, the density reached an infinitely high value due to the extreme compression of matter and energy. The concept of singularity is based on our current understanding of the laws of physics, especially the equations of general relativity proposed by Albert Einstein. Within the singularity, all matter and energy in the universe existed in an extraordinarily compressed form. This high density suggests that an enormous amount of mass and energy was condensed into an infinitely small space. Under extreme pressure and density conditions, such as those present in the singularity, the heat would be unimaginable. The temperature would exceed any temperature that can currently be observed or reproduced in our understanding of the universe. The energy stored in this hot, dense point was the seed from which the entire universe, as we know it, originated. The singularity marked the beginning of the unfolding of space, time, matter, and energy. From that infinitesimal point, the universe began expanding at an incredible rate in an event known as cosmic inflation. In a fraction of a second, space itself stretched exponentially, and the temperature began to drop, allowing subatomic particles to form. As the universe cooled further, these particles combined to create atoms, mostly hydrogen and helium. Over hundreds of millions of years, gravity pulled these atoms together into the first stars and galaxies. This process is what gave rise to the large-scale structure of the universe as we know it today. However, the discoveries made by the James Webb Space Telescope have raised critical questions. How could galaxies so ancient and so small exist so soon after the supposed Big Bang? Why do their properties not align with predictions of early chaotic formation? The smoothness, age, and sheer number of these galaxies challenge the narrative we've held for nearly a century. Some scientists now speculate that the standard model of cosmology may need to be revised, or even replaced. The idea that the universe began with a single explosive event might still hold some truth, but the mechanisms and timelines may be far more complex than originally thought. Alternative theories are being revisited. Some propose a cyclic universe, where the cosmos undergoes endless cycles of expansion and contraction. Others consider the possibility of a multiverse, where our universe is just one of many, each with its own laws of physics and origins. Still more radical proposals suggest that what we perceive as the beginning may not have been a beginning at all, but a transition from one form of existence to another. What's clear is that we are at the edge of a new era in cosmology. Just as Copernicus displaced the Earth from the center of the universe, and Einstein redefined gravity, we may now be on the verge of yet another paradigm shift. The James Webb Telescope, with its unmatched sensitivity and range, has opened a new window into the cosmos, one that may force us to rewrite the story of everything. As more data comes in, scientists will continue to test, debate, and refine our understanding of the universe. What lies beyond the observable edge? What forces shape these newly discovered galaxies? And most importantly, what came before the Big Bang, if there was even such a thing? We invite you to stay curious, stay questioning, and stay tuned. The universe is far from finished revealing its secrets. Universe, the beginning of everything. The beginning of everything in our universe started after the initial singularity. The universe began its journey of expansion and inflation. This process took place over roughly 13.7 billion years, giving rise to the universe as it exists today. The beginning of the universe's expansion was a remarkable and swift burst known as cosmic inflation. During this phase, the universe grew at a rate that was unimaginable, a speed much higher than the speed of light. It's as though space's very fabric stretched and stretched, pulling everything contained within it. Cosmic inflation was a major factor in the formation of the large-scale structure of the universe. It smoothed out irregularities, homogenized the distribution of energy and matter, and prepared the way for the formation of stars, galaxies, and other cosmic structures. As the universe continued to expand, the rate of expansion slowed down over time. It is important to note that despite the rapid cosmic inflation during the initial period, the universe's expansion became measurable. This expansion is known as cosmic expansion, or simply the universe's expansion. Scientists have witnessed the results of this expansion through a variety of observations, such as the redshift of light from distant galaxies. Redshift indicates that light waves expand as the universe expands, being stretched and shifted to longer wavelengths that move them closer to the red end of the spectrum. During the expansion, all the matter that makes up our universe was once compressed into an incredibly small volume. Matter cannot survive in such a small space, so transformations occurred as the universe expanded and cooled. Particles such as protons, neutrons, and electrons began to interact with the energy and light around them. These interactions played a significant role in the formation of matter in the early universe. In the minutes following the initial explosion, this process, known as nucleosynthesis, took place. Unordered and chaotic galaxies due to multiple collisions were anticipated to be observed, but the pictures tell a different story. The images captured by the James Webb Space Telescope, JWST, do not show chaotic galaxies at all. Instead, they reveal spiral and well-organized disk structures, similar to the galaxies we see in today's universe. This unexpected observation casts doubt on the notion that galaxy mergers were common processes in early cosmic evolution. If these new galaxies experienced few or no mergers, it becomes increasingly unlikely that small galaxies would have expanded and transformed hundreds of times over, as previously expected. This implies that these galaxies never shrank in size originally. In addition, the optical illusion predicted by the expanding universe model, where objects appear smaller as a result of expansion, fails to hold in this case either. Therefore, what we have believed so far may turn out to be false. Moreover, the age and number of galaxies discovered by the James Webb Space Telescope challenge the foundations of the Big Bang theory. JWST is equipped with filters that allow imaging in the infrared part of the spectrum, which facilitates the study of the hues of faraway galaxies. By analyzing these colors, astronomers can estimate the age of stars and galaxies. These revelations have sparked a wave of new discussions in the scientific community. Many researchers are now re-evaluating long-held assumptions about the early universe, galaxy formation, and the timeline of cosmic evolution. The James Webb Space Telescope, with its unprecedented sensitivity and reach into the distant past, is rewriting the cosmic story we thought we knew. One of the most surprising findings is the presence of mature galaxies in a time when the universe was expected to be too young for such structures to exist. Some of these galaxies formed only a few 100 million years after the Big Bang, a period when stars and complex systems were not believed to have had enough time to evolve. This forces us to reconsider the speed at which galaxies can form and organize. Another aspect challenging our models is the unexpected brightness of these early galaxies. They are more luminous than predicted, suggesting either unusually high rates of star formation or entirely new physical processes we don't yet understand. Could there be unknown mechanisms at work in the early universe? Could our measurements of cosmic distances and timelines need revision? Some scientists are exploring alternative theories, including modifications to the Big Bang model, or even more radical proposals like bouncing cosmologies or emergent universe frameworks. While these are still speculative, the data from JWST has opened the door to fresh thinking and deeper inquiry. Furthermore, JWST has begun to detect signatures of complex molecules and elements in regions previously considered too young for chemical enrichment. This raises new questions about the origins of life's building blocks and how early they could have formed in the universe. In essence, the cosmos is revealing secrets we never anticipated, reshaping not only our understanding of astronomy but also our place within this vast and mysterious universe. The journey of discovery is far from over. Each new image, each spectrum analyzed, adds another piece to the grand puzzle of existence.